In this lesson, we are going to learn how to determine slope using points on a line. So in the previous lesson, we learned how to find it using rise over run, but we are now going to look at using points. If you look at this example here, we have a line that we could easily find rise over run for. Let's compare the coordinates of those points when we do the rise over run and see the relationship between them. The first coordinate right here is at 1, 5, and the second coordinate is at 3, 8. So if we're looking at the rise from these, if we were to go in an upwards triangle, we would be doing a rise of 3. Now the rise is the change in y's. Notice how we're going from a y coordinate of 5 to a y coordinate of 8. That is a change of 3. If we look at our run, we're going 1, 2. We're going a run of 2. If we check our differences in our runs, we are going from 1 to 3, which is a change of 2. So there is a relationship between the rise and the run and the difference in your coordinates. And here is the relationship. If we know that it passes through two specific points, we can call those points coordinates x1, y1 and coordinates x2, y2, and then use the following formula to find the slope. We would take the difference between the y coordinates and we would divide it by the difference between the x coordinates. So y2 subtract y1 over x2 subtract x1. So for example, what is the slope of a line segment that has points -3, 6 and 5, 2? Well, we can use our slope formula. y2 minus y1 over x2 minus x1. M represents the slope. That is the variable we use when we are talking about slope. And we can label these points. I'll label the first coordinate x1, y1, and the second coordinate x2, y2. So now we can substitute the values into the appropriate spots. y2 is 2, y1 is 6, x2 is 5, x1 is -3. Make sure you're subtracting -3, because what we are ultimately going to do there, we are ultimately going to end up adding those values. So we end up with -4 over 8, which can be reduced to -1/2. So our slope is equal to -1 over 2. If you would have graphed these points, you would have found your rise to be -1 and your run to be +2. So let's look at this next example. We have again 2 points. We can use our slope formula. And again, we can label these as x1, y1 and x2, y2 and substitute them into the appropriate spots. So y2 is 8, y1 is 3, x2 is 4, x1 is 4. 8 subtract 3 is 5, 4 minus 4 is 0. What is 5 divided by 0? If you try it on your calculator, you'll get an error. This is a type of line we discussed in the previous lesson. It is a vertical line. The slope is undefined. Anytime you have dividing by 0, and that is for vertical lines. And it should make sense. The x-coordinate in both cases was the same. So these 2 points are in a vertical line with each other. All right, let's look at example C. Again, we start with our slope formula. We can label this x1, y1 and x2, y2. And we substitute into the appropriate spots. So y2 is -7. y1 is -7, so we're subtracting a -7. x2 is -1, and x1 is -9, so subtracting a -9. When we are subtracting a negative, we end up adding these values together. So we are going to have m equals -7 plus 7 is 0, -1 plus 9 is 8. 0 divided by any number is 0. So our slope is 0, and that means we have a horizontal line. And if you look back at your coordinates, that should make sense. Our y coordinates were both the same, which means we are on the same horizontal line. Equations of lines can be written in a number of forms. A couple of common forms are y equals mx plus b, where m represents the slope of the line. So have a look at that equation and see where the m is located. It is the value that is being multiplied to the x. And the second equation is in the form y minus y1 equals m times x minus x1. And again, m represents the slope of the line. Have a look at where the m is located. It is being multiplied to the bracket that contains the x. So in both cases, m is multiplied to the x value. So if we are given an equation of a line, how can we determine the slope? Well, if we look at the first one, this first one was in the form y equals mx plus b. Where is the m? It's located being multiplied to the x. So in this case, our slope is negative 5. It is not negative 5x, it is just negative 5. The x represents an x coordinate of a point on the line. So the slope is negative 5. If we look at b, we want to find the value that is being multiplied to the x. And in this case, it is 2/3. So our slope is 2/3. In example C, this time we were of the other form where there was brackets. But remember, the m was the value that was multiplied to the bracket that contained the x. So in this case, m is 3, because the 3 is being multiplied to the bracket where the x is located. And in D, same thing. M is 1/5, because that is the value that is being multiplied to the bracket that contains the x.